Hi everyone, this is coming to you from Education for All. Don't forget to visit our website at https://education for all education for all sl.co.uk. Something is coming up on the website soon, so don't forget to visit the website https://educationforall.co.uk. Thank you. We are still looking at transformations, but this time we are going to look at the tangent function. Don't forget, we are still on trigonometry. We've done transformations of the sine function, transformations of the cosine function, and now we are looking at transformations of the tangent function. We have 6 trigonometric identities. Well, these first 3, sine, cosine, and tangent, are just the reciprocal of the other 3. The sine, reciprocal of the cosecant; the cosine, reciprocal of the secant; and the tangent, reciprocal of the cotangent. So when you know these 3, you can be able to work out the other 3. They are sister identities. Now, we're going to sketch the graph of y equals the tangent of x. First and foremost, when we did the sine and cosine functions, we mentioned that the sine function has a period of 2 pi, that is 360 degrees. In other words, it repeats every 360 degrees. Same as the cosine function, itself repeats every 360 degrees. It's a circle. But when you come to the tangent function, it doesn't behave that way. It behaves differently. It repeats 180 degrees. Every 180 degrees, it repeats itself. Why? Why is it different from the other 2? We're going to find out. Before we find out why it behaves like this, let us first go to the unit circle, because this is where everything started. Circle. All these things where they started, from the unit circle. I'm not going to go into depth about the unit circle. We know how it looks like. Here we have our x here. Okay, it's not writing again. Thank you for not writing. We have our x here. This is x, correct? And here is y. This is 1. We call it the unit circle because this is the radius of the circle, yeah? So the radius is 1 unit. Could be 1 kilometer, 1 meter, 1 centimeter, 1 whatever, but it's 1 unit. So if we want to find the trigonometric identities of this triangle we have inside this circle, this triangle here, we already said is 1. This is our angle, theta, and this is our y-axis, x-axis. So from that acronym, we all know they call SOHCAHTOA. We know that the sine of theta here is equals to opposite, which is y, all over hypotenuse, which is 1. So this is 1, y over 1 is just y. And the cosine of theta is adjacent, theta here, which is x all over adjacent over hypotenuse. Hypotenuse again is 1, so which is x. And then the tangent, which is the opposite, which is y, all over the adjacent, which is x. Right? So have these three trigonometric identities. Now, we have y and x. What is y over x? What is y over, we have here y over x. But here we have sine theta is y, cos theta is x. So what is y over x? So this tells us that the tangent of theta is also the sine of theta all over the cosine of theta, which is y all over x. I want us to concentrate on this one. Tangent is equal to sine theta. Tangent of the angle theta is equal to the sine of the angle theta over the cosine of the angle theta. Everything here, all these things, they come from this unit circle. So, now we will use this later on. So now, let's try to sketch the tangent function as we have done for the sine and cosine function respectively. But mind you, we have stated that the tangent function has a period of pi, 1 over 8, pi is 180 degrees. It's not a complete circle, as this is complete circle, 360 or 2 pi. This is a complete circle, 360 or 2. This one is a half circle. It repeats every half circle. It repeats. So how do we translate this information into this graph here? We have the y-axis and we have the x-axis. So let's start sketching this graph. The tangent function is similar to the sine function in the way that they all start from 0. Start from 0 here. That's a 0 here on the x-y axis. This one too, there's a 0 here. Correct? 0 here. The cosine starts from 1. We already mentioned that before. The sine starts from 0. This one to the tangent starts from 0. 0. Now, since we already said that tangent of theta is equal to the sine of theta over the cosine of theta, and we have these two graphs, we are familiar with them. These are easy graphs to remember. So we can use this information to sketch the tangent graph. That is what we want to do. That's why we need this formula here. So let's move on. We don't need this again. This is just a refresher. So we want to sketch since we said that the tangent has a period of pi, it means every 180 degrees it repeats itself. So that's why I have put mark here 180 degrees. It has to repeat from here to here, another from 0 to 180, 180 to 360, 360 to 3 pi. So every 180 degrees it repeats. This side on the right hand side as well as on the left hand side. So I put the crosses here to tell you that it will pass through this point. Every 180 degrees it will pass through this point. So what happens between 0 and 180? What happens here, this gap? And what happens between 180 and 360 or pi to 2 pi? How does it behave in that range? How does the graph behaves between 2 pi and 3 pi? That is what we are going to investigate by looking at the sine and cosine functions. So now, let's see at 0. When tan 0, we know is sine of 0 all over cosine of 0. So sine 0 is 0. Sine 0 is 0. Cos 0. Cosine of 0 is 1. Sine of 0 is 0. Cosine of 0 is 1. So divided by 1. So 0 over 1, 0 divided by 1 is 0. So therefore, this graph will pass through these points. Pass through here, 0 here. So what happens at 90 degrees? Now we have the tangent of pi over 2 to be equal to the sine of pi over 2 all over the cosine of pi over 2. So let's investigate. What is sine pi over 2? We are looking at the sine function. Pi over 2. What is the sine? It's 1. Pi over 2, the sine is 1. You see that? 1. Pi over 2 is 1. So we have 1 here. Now, cosine of pi over 2. Cosine of pi over 2, you see, for the cosine, the graph passes through pi over 2. So pi over 2, here, the function is 0. So divided by 0. Pi over 2 is 0. In other words, cos 90 is 0. And sin 90 is 1. So what do you have here? 1 divided by 0. This one gives us 0. 0 divided by 1 is 0. What about 1 divided by 0? This one gives us that number we call, or that is not a number, something we call infinity or asymptotes. The graph approaches infinity or asymptote. So that means the graph will never touch this number. It will just keep on, it will go towards it, but it will never touch it. So asymptotes in mathematics will draw straight lines. So what we have here at 90, we already said the graph approaches asymptote or infinity. So we draw vertical line here. Yeah? Unless we already stated it passes through 180 because it has a period of 180. So it will pass every 180 degrees, it will cut the x-axis. So we don't need to investigate again. We can still do it. If you want to prove it, as we have done for the 0, it will get the same answer. So now let's see what happens at 3 pi over 2. The tangent of 3 pi over 2 is the same as the cosine, the sine of 3 pi over 2 divided by the cosine of 3 pi over 2. Sine of 3 pi over 2, sine 3 pi over 2 is minus 1. See that? Sine 3 pi over 2 is minus 1. Divided by the cosine of 3 pi over 2 is 0. Passes through 3 pi over 2 is 0. So again, any number divided by 0, infinity. So it means we'll have another straight line here. So we can now claim that the same thing applies here. Likewise here. Same thing applies there. Correct? So this is now the time for us to plot our graph. So since it approaches, the graph never touches this line. It goes towards it, but will never touch it. So if you are now drawing the tangent function, it will, oh, I could have done the same thing here. Oh, sorry. Here again we have, on this side again, the same thing. Yeah? The same thing here. Same thing here. On the negative side. So, it will go towards this, but it will never touch it. It will never touch it. Go towards that. It will pass through pi here. It will come here. It has this S shape, but it will never touch this blue line, because this blue line will have shown that this is our asymptote. This blue line, we have shown it already. So from these trig functions, we have it here, it's blue line, have it here, have it here. Right? So here again, it will never touch this blue line. Go like this, S shape, it will never touch the blue line. Go like this, it won't touch it. So that is the graph of y equals tan theta. Thank you for watching. Bye bye. The next video will be, we'll do a transformation. We'll try to see what happens when we move this graph horizontally. Otherwise, we'll do a phase transformation. Thank you for watching. Bye bye.